Have you ever wondered why the battery cables are massive? Most of the times you're using 4/0 cable for your battery runs. In this video, I'm going to explain why the battery cable has to be so large, especially when you consider long runs. So we're going to spend a lot of time talking about voltage drop and why voltage drop matters when you're talking about battery installations, specifically the battery installations that have an inverter and then batteries, and not necessarily the all-in-ones like the Tesla or the Franklin whole home. But voltage drop is incredibly important if you're working with something like a Sol-Ark 18K or one of the FlexBOSS 21 or 18 models out there. So if you're looking at those particular kinds of products, then this video is going to be extremely helpful in explaining why voltage drop matters and why it's incredibly important to pick the right length of cable and the right type of cable for your battery install. All right, first let's take a look at my house. And this is very applicable to my particular installation requirements for a battery system. I ended up getting the Sol-Ark 18K and Pites batteries. And if you remember from a previous video, I talked about how much storage I was looking for my house. During a typical day, I typically use around 60 kilowatt hours of energy, and I wanted to make sure that I have enough energy to cover that. So I'm looking for anywhere from 80 kilowatt hours to 120 kilowatt hours. Now, during my initial install, I just started with 40 kilowatt hours. It's kind of expensive to go all the way to 120 kilowatt hours. And I'm going to do a video explaining exactly what I did in my battery install. So if you want to check that out, make sure you subscribe to my channel and turn on notifications so you get notified about future content. But let's take a look at my house and then I'll explain kind of what I was trying to do. All right, so here is the side of my house. Now this is normally where we would put like a Tesla or a Franklin whole home. And if we take a look at this, we can see that from here to here, this is around 11 feet. Now, by code, you have to be around 3 feet away from your gas. That only gives me about 7 to 8 feet of usage between here and here. That's not a lot of space, especially when you're talking about a 120 kilowatt hour system being the goal. Now, I could possibly do that with Tesla or with a Franklin whole home and stack pretty much, as high as to let me go. But there's also down here, I have a sprinkler system and this can't be covered. So this space right here really has to be free for access. I can't really cover it up and I can't really relocate it at this point. So it really diminishes the amount of space that I can work with. And that's why I was looking at rack style batteries. Now there's another problem. Obviously you can't put rack style batteries out here. And I live in the city. I don't have a ton of space. I can't just put up a shed and call it a battery house and say that's going to be good. I don't have enough space. I don't think my HOA would even approve it, even though it's in the backyard, but there just isn't enough space in my backyard to do that without knocking down every single tree and then potentially doing a whole bunch of different rework in the backyard. I suppose it's theoretically possible, but I do like having a backyard, even if it is kind of small. I don't even have a 1/4 of an acre, so it's a very small lot that I live on. Again, a typical city house. But as you can see on the side of my house, there isn't a lot of space in here. And on the other side of the house, the far side from this one, I'm not going to show a picture of it, but it's basically the same thing. I've got a fireplace there. I've got another gas hookup, so you're going to be 3 feet away from that gas hookup. There just isn't a lot of space. And on the very back of the house, I've got a downstairs basement access entryway that kind of takes up almost half of the house. There just isn't a good option on the exterior of the house. Now, in theory, I could probably go from the garage and just put everything in there, the Sol-Arks, the batteries, everything. But my garage is like most people's garages, it's jam-packed with stuff. I've got a fairly good sized house. I actually try to put my car in the garage. I've got a lot of tools and a lot of the outdoor equipment inside of my garage. Again, I don't have a shed, so pretty much everything is inside of my garage. But let's take a look at the inside of the house, because this is where things get interesting when you're talking about voltage drop. Now, this is the basement, and right here on this sidewall, this is the same sidewall that my meter and the gas was that I just showed you. And there's the span paddle. I did a video on that last week, actually. So if you want to check out a video on the span and basically all the considerations that I had when I put this in, check out that video. I go through a lot of different things. I'm going to do more content on the span, do a comparison. I'm going to actually do a comparison between some of the other brands that are out there and show you which option might be the best one for you. But this wall right here, as you saw, not a lot of storage space available. If we go ahead and back this up a little bit, you'll see there's pretty much no space here. I guess I could, in theory, get rid of all these tools and all the storage and make it work that way. but there really isn't a lot of space to work with on this wall. And this would be the ideal wall to put everything on because the meter is right on the other side of this. So this would be a great place to put it if there wasn't already so much stuff on that wall. Now, if we go over to the right side here, this is another great place where I could put batteries. Now, the distance is approximately 13 feet, would get you over to here. There's actually a main sewer connection point right over here, so you still can't use the entire wall. Again, there isn't a lot of usable space, and then we've got our sump pump here as well. So you got to go basically between this space here, and then you still got to give them access should there be some sort of a sewer backup where they can use the sewer connection point right here to clean everything out. But I could put batteries right here, and I measured this off. The space that goes basically this wall here is around 13, 14, 15 feet, right around there. And then the distance that you'd have to run from the wall basically to where the Sol-Arks would be on the exterior of the house, that's another 15 feet. So you're talking about 30 feet in distance, just straight line. And then you got to go from the battery bank up to the ceiling. That's around 4 or 5 feet. So you're talking 30 to 35 feet. And then you've got to have the actual battery connections. Again, you have to run everything to a common bus bar when you're talking about 120 kilowatt hours of storage. So you're going to have a common bus bar. I estimated somewhere between 6 and 8 feet for those cable lengths. So you're already talking 40 plus feet to go from this wall here to where the Sol-Arks would be mounted on the outside of the house. Spoiler alert, that's a lot. And that results in a lot of voltage drop. All right, so that is the setup. That's the house, that's the example. My house is a perfect example of where voltage drop matters. And maybe you have a similar situation. Again, if you don't have a lot of wall space, where are you gonna put wall-mounted batteries? Especially if you want a lot of storage. That's where rack batteries are fantastic. But you have to do a lot of considerations when you're talking about putting the batteries away from the inverter. And that's really what causes this particular issue. Now, I might be wondering, well, why can you have these really long runs for your AC? Your entire house is wired and it goes from the main panel all the way to the other side of the house. It works great. Well, a lot of that is the voltage. So you're talking 240 volt AC. It's a little bit easier. You can run into problems there too, where you can actually have some runs that are just too long. Or maybe you're working with outdoor gardens and you're putting in lighting. I actually did this also. And you're working with some really small wires and kind of a low voltage. Usually it's around a 24 volt system. You can hit a point where your lights won't work anymore. You'll have the lights working fine in the beginning and the lights won't work at the end. I actually had that particular issue too. I put in way too many lights and I had to kind of pare things down, not spread them quite so far out. But that's, again, another example where voltage drop matters. When you're talking about battery, you're talking about a 48 volt system most of the time. Sometimes you're talking 12 or 24 volt, depending on your use case. But when you're talking about whole home, it's a 48 volt system. Now, they are starting to move to higher voltage systems for inside the house. EG4 announced that they're taking a look at doing this, I believe this year, actually. They're talking about having maybe a 100 volt system come out of here. I'm going to show you why that matters and probably why they're actually looking at doing that. But remember that your house is running on 240 volt AC, not 48 volt DC. All right, let's talk a little bit about batteries. Now, this is a 48 volt battery system. And this is, again, what I used. You could be talking about the EG4. EG4 has a very similar, very capable battery. I actually considered quite a bit about whether I would go with EG4 or Pites. That was really the two contenders for me. I wanted to make sure I had a UL-based battery, and there are lots of cheaper batteries out there, but they're not usually UL listed. If we scroll down here, let's take a look at some stats here. Now, I said it's a 48 volt system, but if we take a look at this, we've got 51.2 volts. Well, where's that 48 volt? Now, that's just kind of the nominal. That's what everybody uses, is it's a 48 volt system. It's actually a range. So if we come over here, we'll see that we've got a 47.5 volt to a 57.6 volt is kind of the range or the nominal energy that you would expect out of the battery. And what these are usually made out of is 16 3.2 volt. And if you multiply 16 times 3.2, you end up at 51.2 volt system. But for most calculations, people use 48 volts. But I did want to explain that it's a little bit of a range, right? So it can be anywhere from 47.5 all the way to 57.6. And that matters when we start talking about voltage drop here just in a second. I'm going to show you why. All right, now let's talk Sol-Ark 18K. Now this is what I put in my house, was the Sol-Ark 18K. Let's talk about voltage drop specifically and how it relates with the Sol-Ark. And then we're going to talk a little bit about the EG4, just so we have a comparison between how they handle things. So how Sol-Ark does things is they tell you a percentage voltage drop. So all wire runs should be sized to be less than a 2.5% voltage run. So they don't tell you how long the cable can be. They tell you it's got to be under a 2.5% voltage drop. And also keep in mind that the Sol-Ark 18K has the ability to pull 350 amps or push 350 amps back into the batteries, but you have to use 2 sets of battery terminals to actually achieve that. So you're actually talking about 175 amps per battery terminal. So if you run 2 runs of wire, you can take advantage of the full 350 amps. Or what you could do is split it off at the termination point when you're adding it into the actual Sol-Ark, and you could run basically a splitter right there, and then you would run 350 amps through your cable. So in order to do that, you have to use 4/0 cable. And even with 4/0 cable, it tends to get a little warm if you're putting 350 amps through that cable. But it is definitely possible as long as you get good high quality cable. And if you take a look at the EG4, this is where things are a little bit different. And again, all of these inverter companies do things a little bit different. Some of them give you a voltage drop, and then typically for voltage drop, most electronics you're looking at anywhere from 1 to 3%, 3% being kind of the max and 1% being pretty good and acceptable. Now, when we take a look at EG4, they actually tell you how many feet is your max distance. So you don't have to do anything. You just have to figure out, okay, what am I going to use as far as the gauge? Am I going to use 4/0 gauge, or am I going to use the 3/0 or 2/0? 2/0 a lot of people will end up using. I think 4/0 is generally what people expect to be using, but you can use anywhere in between here. But they're telling you that if you use 4/0, the longest your cable can be is 33 feet. Now keep in mind, the FlexBOSS 21 doesn't have the same amperage for the battery. I believe it's at 250 amps that it can pull from the batteries or push back to the batteries. And again, they've got 2 sets of terminals, so actually divide that between 2 terminals, which matters. If you use 1 cable versus 2 sets of cables, it does matter when you're talking about voltage drop. Now, something else that's important to think about is when you're talking about the amperage, when you're talking about what you're pulling from the battery or pushing to the battery, we're talking about 250 amps in the case of the FlexBOSS 21 or 350 amps in the case of the Sol-Ark 18K. But you're actually only providing 50 amps to the house or 75 amps in the case of the Sol-Ark out of the 200 amp service that you've got. So again, you're not providing the full house with what it can actually achieve unless you stack inverters and you put them in parallel. So for example, if you put 2 Sol-Ark 18Ks, all of a sudden now you're at 150 amps. You're almost at that 200 amp that your main panel is rated for if you're running a 200 amp service. So the amperages, even though you're pulling from the battery, when you look at it, you're pulling, in the case of the Sol-Ark 18K, 18,000 watts continuous, right? So that's what the Sol-Ark 18K can do. Well, that translates to 75 amps being provided through the inversion process to get it from 48 volts to 240 volts, which is what the house needs. So keep all that kind of stuff in mind as we're talking about this. And I'm going to show you exactly what this looks like here in a few minutes as well. Now, I might be wondering, why does any of this even matter? What happens if your voltage drop is way too high? So for example, maybe with the Sol-Ark, you're at 3% or 4%. What do you see with that? Like, what is it actually going to have a problem with? Well, from the inverter's perspective, it may not be getting everything that it needs from the batteries. So it's seeing that there's potentially an issue with your batteries and might start throwing some faults. And if you're getting these kind of random faults, maybe there's a fault that specifically is addressed that the inverters have identified, hey, this is what a voltage drop issue would look like. I don't believe they have, because there's so many different things you can run into, whether it's on the battery side or on the inverter side. So essentially your system just won't be efficient and won't be working, and you'll probably be getting a lot of faults or potentially shutdowns if it's trying to pull too many amps or it can't pull enough amps. So you might run into a lot of really strange issues if your voltage drop is too high. You'll get things like earlier low voltage, and you'll get less usable energy from your system. The other thing that you're going to get is heat. So your cables and all your connection points are going to get a lot hotter because everything's working a lot harder because of that voltage drop. Not to mention, you're making everything work harder, so your Sol-Ark or your EG4 or your Bytes or your EG4 batteries may not last as long because you're working the entire system a lot harder than it needs to. All right, so let's talk actual information here. So this is a voltage drop calculator that I got hold of, and this is essentially the calculation. So you don't need this kind of a calculator. This is everything that you need right here. both for single phase and for three phase. Now, single phase, we're also talking DC, AC, anything in that kind of a realm, this equation will work for. If you're in a three phase setup, then you're going to want to use this equation right here. And then there's a voltage drop equation here that tells you the percentage, because again, Sol-Ark and some of the other inverters out there use a percentage instead of this is the number of volts you can't drop below. So this essentially will achieve all of those parameters here. So let's walk through this. We've got our voltage drop is equal to 2 times, and if we go down here, K has a copper constant of 12.9, an aluminum constant of 21.2. So the type of material that you use, whether aluminum or copper, also matters. Now, another thing that does matter is temperature. I didn't really factor that in. This equation here is kind of everybody uses it, especially on the electrician side, but there are other equations out there that factor in other things such as temperature. And then there's another equation that does for long distances. So there are different equations out there. Let me know in the comments if there's a specific equation that you use, or do you use this one. I'd love to hear what you guys are using. And then we've got our I, and I is our current in amps, and then we've got the length. Now in this particular one here, because we add these square root of 3 or the 2 to it, this is one-way distance. If you didn't use the one-way distance and you went full round trip, then you wouldn't necessarily need to use the 2 or the square root of 3. So just keep that in mind. I tend to think this is a little bit more accurate than doing the round trip, and it's just easier because you know the distance to get there. You don't have to double it and then figure it out. It's just follow this equation here, and then again use that one-way cable length. And then we've got is your circular mills. So every cable type, whether it's 4, 3, 2, has a specific circular mills that's listed in the NEC code book. Now, in this case, all of that information is in this tool, so we don't have to worry about looking anything up. Now, let's go ahead and plug in the numbers for my house, right? So we went with a 4-aught cable. That was what I was going to use for my house. I was going to use copper. And then for the circuit type here, I went with a DC. Now it is a 350 amp, so we'll go ahead and put that in there. And it is a 48 volt system. And then our one way, let's just say it's 45. Well, we can see that 45 is 4% voltage drop, way beyond what you can do with the Sol-Ark 18K. Now, this is assuming one cable. Each cable, let's say we ran 2 separate cables instead of just dividing it and using 2 ports there. This is using 1 cable. So let's say 2 cables. Now that's 175 amps each. So now we're at 2%. So if I ran 2 sets of cables, 2 red, 2 black, from my Lynx distributor in my basement all the way to the Sol-Ark 18K, I could make this work. I'd only have a 2% voltage drop. Now remember, we said that the voltage is a range, and it was around 47 all the way up to 57. So that matters. Let's say we put it in here at 51.2. Well, it even gets better when we're talking about what the actual 16 batteries actually calculates out to at 51.2. But if we start going into, I think it said 47.5 or something like that, now we're going up a little bit higher. It's not so bad. It's definitely within the range. But we're not talking about what happens when things heat up. So when the system's under load and all the cables and everything start to heat up, that has a huge impact. There's also a little bit of an impact if your conductors are outside, for example, and it's cold, or if it's hot. Colder is usually better, hotter, not so much. So you want to keep everything kind of cooler. But it's really how much everything is heating up under load that matters the most. Let's go ahead and put this back in here at 48. So now we're talking about, in order to do the Sol-Ark 18K, 175 amps, it is 2 sets of conductors. Now, right now, I've got 8 batteries for 40 kilowatts. I plan on adding another 8, another 16 to get to 120 kilowatt hours of storage. In addition to that, I'm going to add another inverter. So we go from 350 amps to 700 amps, potentially, that we're going to run through parallel inverters for 18Ks to get to providing the house with 150 amps of usable power. What does that do to everything? Well, let's go back to 350, because now I've got 2, and if I didn't increase the number of cables, so I've got 2 reds, 2 blacks, I've got 48, and it's still 45, we're right back to 4%. So we've again exceeded everything. I would need to add more cable runs. So again, I would need to double everything in order to make this work. So we'd have to drop it back down to 175 amps. Now, again, this is a roundabout distance, right? So let's say we don't want to add more cables. Well, how long could this be before I'm going to blow the equation at 48 volts? Well, let's go ahead and put 28 in there. 28 feet is the max. Well, based on the layout of my basement, that's not possible. So I have to make the decision of either run a lot of runs in order to support 2 inverters down the road. That's a lot of cable. That's a lot of copper. It's not necessarily from a price. It's just my entire ceiling in my basement would be essentially cables next to the door. So it's just a lot of cable to run between the batteries and the Sol-Arks. Now, what about the EG4 FlexBOSS 21? Now, remember, they have 250 amps. I believe that was the correct number. So we'll do 250. And their length was 33. So that's at 2.1%. If you do 33 feet, again, this is one cable. Again, they have 2 terminals, so you could run 2 sets of cables, just like we did with the Sol-Ark example. And then this would divide out to 125 amps, and then we're right around 1% voltage drop. Now you might be thinking, well, what if I have the EG4 and I want to go further? Well, you'd want to reach out to EG4 or Signature Solar and ask them, how do they do these calculations? How do they come up with 33 feet? Are they assuming that you're going to have one run? So you're going to have around 250 amps on 33 feet, which again puts you at 2.1%. Again, a little bit less than what the Sol-Ark team has come up with 2.5%. So maybe there's a little bit of wiggle room in their numbers. They're planning that you may have less efficiency on some of your connections or some other thing that they're building in a little bit of flexibility here. Or maybe the EG4 FlexBOSS just does better if it's around 2.1% and not any higher than that. All right, let's go ahead and set this back at 350 quick. And we're going to talk about something else that's pretty interesting here. Let's say it's 28 feet. So that takes us to 350. So that takes us to 2.49%. So we're maxed out. Now there's a lot of talk about going to higher voltage batteries. EG4 is talking about it. There's some other products out there that are already doing it. We seem to be seeing a transition to higher volt batteries. So instead of 48 volt, basically doubling it. So taking, instead of 16, it's 32. And then we get to a 96 volt system. Well, look at this. It drops the voltage drop significantly. So now we can go a lot further with that cable. And for a long time, I kept looking at the battery stuff, wondering when we were going to do this, because it just makes sense to try to get as high a voltage as possible in order to get this voltage drop to be less of an issue for long runs. Plus, if it's a higher voltage, the inverter doesn't have to work as hard to change that voltage, because it's got to get it to 240 volts. So now let's talk about what happens if we could get all this all the way up to 240 volts. Then we're talking about a voltage drop that's minimal. We could do like 280 feet. Well, maybe not that much. Let's try 100 feet. So yeah, you could do 100-ish feet or more. So you could have your batteries much, much further away from the inverters if the voltage was a lot higher on the battery system. So this might be why you're starting to see a lot of manufacturers take a look at higher voltage systems, is it allows you to put those batteries a little bit further away. Maybe you don't want them in your house. Maybe you want to have a longer DC run versus putting the inverters and the batteries someplace else. There's more flexibility with these high voltage batteries over 48 volt. And 48 volt is a lot better than it used to be with 24 volts. So things have gotten a lot better. It's only going to get better if we go higher on the voltage of the batteries. But at the very least, I've showed you how you can calculate how far away you can put your batteries and still not have an issue. Now, closer is always better. The less voltage drop that you have, the more efficient your system's going to be, the better for you. So I always try to put your batteries as close to the inverter as possible. But if you're in a situation where you have to do a lot of redecorating or you have to move a lot of stuff around, it is definitely possible to move those batteries further away. You just have to keep in mind voltage drop. Voltage drop is king when you're talking about moving batteries further away from the inverter. And this is also a reason why you would see all-in-ones that have the inverter along with the battery right there. For those all-in-one systems, everything's right there. So all of your battery runs are very, very short. It's all integrated into the same equipment. They have a lot less issues with this particular problem. All right, that's pretty much it for today's video. Hopefully you found the content helpful. Don't forget to hit that like and subscribe button. It really does help the channel grow. Until next time.